Okay, we're gonna see how to rationalize complex numbers. The way to rationalize complex numbers basically is one out of two options. Option one is you multiply by imaginary unit, or option two, you multiply by the conjugate of the number. How do we know when to use option one and when to use option two? We use option one only when there is one single term on the denominator, and we use option two when we have a complete complex number of two terms in the denominator. The word conjugate might confuse some people, so we're going to explain it. How do we find a conjugate? Or what exactly is a conjugate? A conjugate is basically the same number that we have on the denominator, only that changing the middle sign of it. For example, the conjugate of 3 plus 2i would be 3 minus 2i. If you notice, I'm only changing the middle sign. Yes? The rest, I'm just copying it. Same thing if we have the number minus 2 minus 4i. The conjugate will be minus 2 again, but in this case not minus, plus 4i. So it's pretty simple to know how to find the conjugate. Now let's try to solve some examples to see how to apply this in actual exercises. So let's assume we have a number like this one, 3 over I. How do we rationalize this number? In other words, how do we get rid of the I on the denominator? We use option 1. We're going to multiply by the imaginary unit. So we're going to put a dot in here, and we're going to multiply up and down with the imaginary unit. What is this going to give us as an answer? If we multiply these things, we will get 3 times I, give us 3i. I times I is going to give us I squared. Now you know that I squared is going to be transformed into -1. So what I have in here is 3i divided by -1. Once I eliminated the I can divide these numbers normally. 3 divided by -1 is -3. And I just copy the imaginary I. And that will be the answer for this exercise. That's how you rationalize when you only have one term. That will be example number 1. Now let's see example number 2. What would happen if we have something slightly different? For example, 4 divided by -5i. Are we going to multiply with the same -5? No. Remember, the options are only two. You multiply by the imaginary unit, or you multiply by the conjugate. Because there's only one thing here on the denominator, only one thing down, we're going to multiply again with the imaginary unit. We multiply with I up and down. Once we do that, we're going to get the following answers. 4 times I is going to give me 4i. And -5i times I is going to give us -5i squared, because I times I gives you I squared. Now remember, the I squared is going to transform into -1, so we have 4i up and -5 times -1 down. This is going to give us 4i divided by +5. In this case, if you divide, you get a normal decimal. You get 0.8. So that is a valid answer if you decide to leave it as a decimal, or if you decide to leave it as a fraction. We could put 0.8i, and that will be the answer for that exercise. If you notice, we're just multiplying with the imaginary unit every time we only have one thing here. If we have only an imaginary number, we multiply with the imaginary unit. Another example would be exercise 3. If we have 1 minus 2i divided by 3i, again, we have one single term down. So we're going to use, again, option 1. We're just going to multiply with the imaginary unit. So when are we going to use option 2? Okay, we're going to see it eventually. In this case, because we have two numbers, two parts for the complex number, we're going to have to multiply both of them with I. And then on the denominator, we're going to multiply the 3i with I. So in this case, we have 1 times I, that will give us I. And -2 times I times I, that will give us -2i squared. Divided by 3i times I is 3i squared. Now those I squared are going to change to -1. So we have I minus 2 times -1 divided by 3 times -1. both of the I squares are going to change to -1. So we continue the exercise in here, and we are going to get -2 times -1, +2. So up we have I plus 2. And down we would have 3 times -1 is -3. What we do is we organize the numbers up. That will give us 2 plus I divided by -3. And then we divide. Now in this case, if we divide by 3, we're going to get recursive numbers like 0.66666, etc. So we're not going to do that. We're going to leave it as a fraction. What we do is we divide 2 up, okay, divided by -3. 2 divided by -3 is going to give us plus and minus -2 over 3. We leave it as a fraction. And then there's an invisible 1 with the I, so it's 1 divided by -3. Positive 1 divided by -3. Positive and negative are going to give us a minus. And 1 divided by 3 is just 1/3. We copy the I, and that will be the answer for our exercise. So we have seen already how to deal with case 1, when we need to multiply with the imaginary unit. Now, what about case 2, when we need to multiply with the conjugate? Let's see some examples. Okay, example number 4. Let's say we have this thing, 2 divided by 3 plus I. In this case, we don't have one single thing down. We have two things, right? We have a real number and an imaginary number. So in this case, what do? We cannot multiply by I in this case. When you have two things down, you're going to have to multiply with the conjugate. What is the conjugate? You copy the same thing, but you change the middle sign. In the middle, I have a plus, so I'm going to change it with a minus. And I will get 3 minus I. That's what I'm going to multiply with, up and down. So if we multiply that with 3 minus I, we would get 2 times 3, 6. 2 times -I, that will be -2I. Down we have two things times another two things. So we're going to have to use distributive property. 3 times this 2 and I times this 2, right? So we're going to have 4 answers. 3 times 3 is going to give us 9. 3 times -I is going to give us -3I. I times 3 is going to give us +3I, and I times -I is going to give us -I squared. That will be what we have down. So in this case, if you notice, what we have down, at least part of it is going to get cancelled. This -3I with this other +3I, they're going to get cancelled with each other, right? Because -3 plus 3 gives 0. So what we would have in this case will be equal to 6 minus 2I divided by 9. Remember the I squared is going to change to -1, right? So 9 minus -1. If we continue, we will get 6 minus 2I divided by minus and minus plus. So double minus is plus, so we have 9 plus 1. That means we are going to get 6 minus 2I divided by 10. If we divide both of them, because we need to divide both of them by 10, in this case we will get 0.6, it's a normal decimal, minus 0.2I. And that will be the final answer of the exercise. So remember, when you see those kinds of numbers, when we see two numbers down on the denominator, we're going to have to use the conjugate option 2. Let's see another example. This will be the final example that we're going to try to solve. Example number 5. We have, let's say, 4 plus I. In this case, now I have two things up, divided by 2 minus 3I. So what do? Same thing. Because I have two things down, I'm going to have to multiply with its conjugate. So instead of minus, I'm going to use plus. 2 plus 3I. Remember always to change the sign. So it'll be 2 plus 3I up, and the same 2 plus 3I down. You need to multiply up and down with the same numbers that you use. So if we multiply that, what are we going to get? because we have two numbers, and two numbers, we're going to use distributive property, and we're going to get 4 answers up. And we're also going to get 4 answers down. So this is going to be a little bit long. 4 times 2 gives 8. 4 times 3i gives 12i. I times 2 gives 2i. And I times 3i gives positive 3i squared. That will be the answer up. Now let's see what will be the answer down. 2 times 2 gives 4. 2 times 3i gives positive 6i. Negative 3 times 2 gives negative 6i. And negative 3i times 3i gives negative 9i squared. Now, the positive 6i with the negative 6i are going to cancel with each other because 6 minus 6 is 0. So we just continue here, and it will give us 8 plus 12 plus 2. Those two are like terms. This one is not because it's I squared. So those like terms, I'm going to add them. 12 plus 2 is 14i. What do I do with the I squared? I'm going to change it with a minus 1. So I have 3 times negative 1 divided by 4 minus 9. Instead of I squared, I'm going to use negative 1. So I have negative 9 times negative 1. If we multiply those things and then we copy the rest, we're going to get 8 plus 14i minus 3, because 3 times negative 1 is negative 3. And down we're going to get 4 plus 9, because negative 9 times negative 1 is positive 9. If we continue this way, we're going to get 8 minus 3, we can subtract. It's going to give us 5 plus 14i. And on the denominator, if we add 4 plus 9, that's going to give us 13. Now, 13 is a really complicated number to divide with, right? So when we divide both of these numbers with 13, we need to divide 5 with 13, but we also need to divide 14 with 13 too, because 13 is dividing both of them. It's going to give us some ugly numbers. It's going to give us a rational number, a recurrent decimal. So instead of writing a decimal, we're going to leave it as a fraction. We're going to leave it this way. 5 over 13, okay, because 5 divided by 13, ugly number, so we leave the fraction, plus, because positive divided by positive give us positive, right? 14 divided by 13, same idea, it gives us an ugly number, so we're just going to leave the fraction. 14 over 13, and we copy the I, and that will be the answer for this other exercise. So that is how we rationalize complex numbers. We either multiply by the imaginary unit, that will be option 1, or we multiply by the conjugate, that will be option 2. Those are the ways we rationalize complex numbers.